did the chapters, would you like us to already have read the chapter going into class, or?
That'd be really nice.
I'm trying to think of what the ideal would be. I mean, the ideal is that no one makes careless errors, since I'm dreaming. Yeah, I recommend not waiting till after I'm done with a chapter before you start looking at a chapter. So, and just other questions? I wasn't sure, Jack, if you were speaking for the entire class and you shook your head no, or just for yourself, but apparently it was the entire class. So congratulations on being the spokesperson.
Thank you.
What's the hypotenuse?
It is the diagonal line.
Oh, I was looking for the length of the hypotenuse.
Oh, 100.
Pardon?
100.
That's a bit extreme.
Um,
The hypotenuse can never be more than the sum of the other two sides.
With 7?
Pardon?
With 7?
No.
10?
How'd you get 10?
I used c squared equals a squared plus b squared. I like-
Okay, Pythagorean theorem?
Yeah,
Okay. Yeah, that's one way of doing it. Why are you allowed to use Pythagorean theorem here?
because it's a right triangle.
Yes. All right, so one method is to notice that it's a right triangle, so 6 squared plus 8 squared is equal to the hypotenuse squared. So in which case that would become 10. Or similar triangles that if I'm going from this triangle to this triangle, I double it to get 6, I double that to get 8, I'm going to double that to get 10. The term similar triangles, is this somewhat familiar or unfamiliar? I'm getting some thumbs up and some sideways motions. Similar triangles are two triangles where the sides are proportional to each other. So if I can take this triangle and multiply each of these sides by a particular value, I'm going to get a similar triangle. In essence, a similar triangle will have the exact same angles. So this angle here is going to be about 53 degrees, just because I've done this enough. That's going to be about 37 degrees. That's going to be 37 degrees. That's going to be 53 degrees. So the angles are going to be the same, and the sides are proportional. This is the essence of right triangle trig. So in doing right triangle trig, once you accept that the sides are proportional, I know that this side divided by that side, so 4 divided by 3, it has to be this side divided by that side, since they're similar. Or you could just look back at fractions and you know that those are equal. But the fact that this opposite side here, that if I'm in a room with 3 sides to it, I'm standing in this corner right here, that's me right there at the dot. If I look at the length of the opposite side and then the length on the one just to my right, it's going to have the same proportion. So if I take any triangle, any right triangle I should say, and that's a 53-degree angle, I know that this length divided by that length is going to be 4/3. So if that is 10, this is going to be, doing the fancy math here, 7.5. I'm just going to label that as A. Let's see if we can do this without having to do it all in my head. Since they're similar triangles, again, right triangle, 90 degrees, 53-degree angle. The sum of angles in a triangle,
180.
I'm being picky here.
Degrees.
Thank you, there we go. If you don't say the unit, what are we talking about? With angles.
Radians.
That's the one, yep. All right. So that adds up to 180. So if this is, we'll say alpha. Alpha plus 53 degrees plus 90 degrees is equal to 180 degrees. Divide, or subtract 53 and you get 37 degrees. So it's a similar triangle. So standing in this corner, my opposite side over to the adjacent side has got to be equal to 4/3. And then doing the fancy math there, A is equal to 34ths or 7.5. If you are dependent upon your calculator, use it. All right. Now, it's a real nuisance if I have to say, well, you're standing in a corner, it's the opposite side divided by the one to my right. We obviously have to come up with better terminology than that. Or someone did. We just benefit from it. That ratio there is also known as the tangent, which would help if this would write. Oh, I think I did it right. Black on black. There we go. The tangent of the angle. Which angle? Because I got 3 of them there. It's the angle for the corner I'm standing in. If I'm standing in this corner, it's the tangent of 53 degrees is that divided by that, which is 4/3. Or the opposite length divided by the adjacent length. And what we mean by adjacent is not the hypotenuse. And again, I know some of you have done trig already, and this stuff is second nature to you. I just will get past it soon enough. Now we have a couple other ratios here, because I've got 3 sides here. If I pick any 2 of them, I've got 3 different combinations straight off the bat. So that divided by that is 4/3, otherwise known as the tangent of 53 degrees. The tangent of 37 degrees, so if I'm in this corner, well, the opposite's now this, so the tangent of 37 degrees is 3 divided by 4. So I can just do specifics for this case. So the tangent of 53 degrees is 4/3, and the tangent of 37 degrees is 3/4. And that is a sad little marker. Now, if you went onto your calculator and you typed in 37 degrees tangent or tangent 37 degrees, whichever type of calculator you have, it will not come out to be 0.75 exactly because those angles are rounded. I think it's 36.82 something. Well, let's find out what it is. So, if I've got that the tangent of some angle is 3/4, and I want to figure out what that angle is, in algebra, how do you solve for an unknown?
You could look at X, or like put in a variable.
Well, theta is a variable.
Oh.
We could put a different one in if you really are hating against the Greek letters.
You isolated?
Yes. So we need to somehow get this tangent away from it. But how do you get rid of tangent? You don't divide by it because these are linked to each other. It's not like it's 2 times x. It's not tangent times theta, it's tangent of theta. Tristan, yes?
Multiply by 1/10?
No, that would be like dividing by tangent. Again, they're linked to each other. We can't just, multiplication and division is not enough.
Substitution. What else on
That probably could do a substitution thing, but that's gonna be long and complicated.
Is it arcane?
There we go. Thank you for using arc instead of inverse. The way you undo trig functions is you do the inverse or arc of it. So what you would do is do the arctan of both sides. And arctangent of a tangent is just the angle, so those neutralize each other. So I'm left with theta on the left-hand side, and on the right-hand side, I'm left with arctan of 3/4. Now, most of you, I'm guessing, have a TI-80 something calculator. Anyone cool enough to have an HP? RPN calculator? You're just not nerdy enough. This is the place you can let the nerd flag fly. All right, so most of your calculators are not gonna have arctan on it written like that. My calculator doesn't write out arctan, it abbreviates it to atan. And so this is the same as arctan, so in class I will often just write atan or acos or acin. On your calculators, it'll probably have that, tan raised to the -1 of 3/4. If you have your calculator, what do you get?
36.869.
Let's finish it off. There we go. I heard somebody say it very gently, quietly. It's still rounded off, but it's more accurate. There was one test where I actually gave it out to 10 decimal places. So an object's being thrown at 36.869, et cetera, et cetera. And that way, if you put it into your calculator, it would come out exactly at, the tangent would come out exactly at 0.75, as to something close to it. And I wrote down there, cosine of this is equal to, and I gave the very specific values, so they didn't have to use a calculator to figure it out. And some people still took that, rounded it off, came out with answers that were just a little bit off of what the right answer was. Did more work than they had to do. Questions up to here? All right, let's get the other two big trig functions that we need. So we have tangent, still written up there, opposite over the adjacent. But we still have the hypotenuse we haven't dealt with, so we have to have some combination of opposite and hypotenuse, and adjacent and hypotenuse. And you're in luck. It's been done. Let's see, I like that. Apparently that's not it. So they've upgraded or I've forgotten how to do it. Looks like I forgot. All right. We have what is known as the cosine of this tan right here. This is short for tangent. Cosine, abbreviated COS, is the adjacent length. Divided by the hypotenuse. And then sine of theta, abbreviated, just dropping the E, is the opposite length of the hypotenuse. Now, if you're having trouble remembering it, this is basically how I learned it, and somewhere between when I took it and when I taught, they came up with SOHCAHTOA. There's also longer ways of remembering it. But the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent, which, if someone says SOHCAHTOA, they're referring to this. So based upon what we have right there, the cosine of 53 degrees. Well, I'm standing in this corner. Cosine is the adjacent length over the hypotenuse, so that's 3 divided by 5. So that's 3/5, or 0.6 for the decimal fans. Sine of 53 degrees. Mike, you mean it? No, I was saying just louder and with more confidence.
4/5.
All right. Yeah, there are no units there. Or if you want to throw in units, the units of 4 and the 5 would have the same units and they just cancel out. Now, physics teachers and, well, probably physics teachers a lot, really like 37, 53, 90 triangles because it's close enough to 3, 4, 5. It just makes life simpler. Questions up to here? Cosine of 37 degrees. So we're in this corner.
4/5.
Sine of 37 degrees.
3/5.
So when you're dealing with the complement, so 90 degrees minus that, you just flip over from cosine to sine or sine to cosine. So if the cosine of theta is 0.3, whatever that angle happens to be, the sine of 90 degrees minus theta would also be 0.3. Just move it into the other corner. All right, so I know what you're thinking right now. You're thinking, I came here to do physics, all we've done is math. Where's the physics? All right, because you want it, let's do some physics. There it is. I'm assuming you have this either in mind or written down, because I'm about to erase it. I apply a force in that direction. Force has a magnitude of 75 newtons at an angle of 28 degrees. Now, as far as writing it goes, almost all of my angles look like 45-degree angles or 90-degree angles. So you have to go with not how I've written it, but how I label it. So if I have a force that is going off at that, in that direction right there, how much of that force is up? How much of that force is to the right? So what we're going to do is we're going to break this up into smaller forces. So I have a 75 Newton force going off in that direction. I need to know how much is going to the right, how much is going up. And so I know I'm going to just label that as A and B for right now. I know that the cosine of 28 degrees is going to be the ratio of that length over the hypotenuse. I know that the sine of 28 degrees is going to be the ratio of that length to that side. And for the fun of it, the tangent of 28 degrees. So let's make it official, that's a right angle there. Is going to be B divided by A. the less useful of the three at the moment. So how do you solve for A?
Isolated.
Okay, so and specifically,
Multiply 75 newtons over.
yeah, so you multiply both sides by 75 newtons. They cancel out on the right-hand side, and what I'm left with is A is equal to 75 newtons times the cosine of 28 degrees. And the answer is, if someone be kind of, so, actually, it's usually helpful for more than one person to crank it out. If you don't have your calculator with you, I do recommend that you make sure you know how to use your calculator, so, at home, see if you get the same answer.
Like 66.2,
Say it again?
is it like 66.2?
I'm happy to trust you there. Anyone else get somewhere around 66.2?
So that's 19.41.
I will say that I know it has to be more than 37 and a half.
Now, would you happen to have, got negative 72.1954?
Are you in
change-
radians?
Yeah, change
Oh.
your thing to degrees.
Oh,
And the other one could be that if you
yeah, that's 66.
if you flip the numbers, maybe. That still doesn't. Carolyn, did you?
I got 66.2, etc.
Okay. All right, so we got at least two people.
Oh,
we got a third. We got it. All right. It seems to be a groundswell. And by the way, I think this is in one of the videos, but if you see that I've made a mistake, pointing it out as soon as you realize it is helpful. There's basically two of those size boards that started over there, worked all the way throughout here, got an answer which I knew was wrong, and then trying to figure out where the problem was, and someone said, oh, you made a mistake over there.
I got 66.22.
You got the same thing again? All right. However, I would take off for that answer if that's what you presented on the quiz or test.